Hey guys, what is up? This is Kazi from Clever Programmer, and you're watching Codecademy Part 5. Okay, so let's get started. We left off at functions. That's where we're going to pick up from. We just got done completing Pig Latin. I got some coffee with me. Hopefully you have coffee with you as well, or you've already had some food in you, and you're ready to, pound through this. Okay. Let's get going. What good are functions, right? What are basically functions used for? And that's going to be the thing that we're going to figure out in this section. So they've already written up some code here, but we're going to hit save and submit, and we're going to continue and figure out on our own why we use functions. Cool, so let's get started. Okay. So here I can tell you a little bit about what's going on. Okay, so they have a function called tax, and it does these things here. It takes bill, it multiplies it by 1.08, it prints out this stuff, and then returns bill at the end. It's also dependent on one input. So here you can see it's dependent on an input bill, and this other function. So this function is called tax, this function is called tip, and then once we're finished defining these functions, we later call them over here. So you call this function tax right here, you pass in one input, meal cost, so it goes to this function tax, bill becomes meal cost, and everywhere you see bill, it's effectively meal cost, and it does the math accordingly. Okay, so we're going to explore this in more depth. That was just a very, very, very rough overview. So in some simple way, how I like to think about functions is, let's say you wanted to store a variable, right? You wanted to store a bunch of numbers and save it as a variable. What you would do is, instead of always, right, I've explained this before, writing this big number out, what we can do is we can call it some variable, and now we can just refer to v, or that big number, as v. Well, what if you wrote a block of code, right? And you wanted to use that block of code over and over again. You can't call it v and say print 5, print 7 plus 8, and I don't know, print hello. Right? Now you can't just go at the bottom and say print v, and it's gonna output 5, what is 7 plus 8, 15, and then hello. You might think this is what it's gonna output on that black screen to your right, but that's not actually what's gonna happen. What's gonna happen is it's gonna give you an error, because it's gonna say you can't assign a block of code to one variable. But if you were to do something like this, right? You said define v, and it's not dependent on any inputs. Now, if you actually did print v like this is gonna happen. It's gonna print out 5, then it's gonna print out 15, and then it's gonna print out hello. Okay? So functions give us a way to name blocks of codes, and there's much more that goes into functions, but this is a very simple way to look at it, okay? All right, now let's look at a little bit of their explanation. Function junction, header, parameters, and comments, and then, okay, so header, parameters, body. Cool. All right, let's see what they're talking about. So they want us to create a function called spam, and what it should do is print out eggs. So let's do that. I'm going to define spam, and I'm going to say print eggs. Boom. Oh, they want us to write a comment, or a doc string here is what they call it. Prints eggs to the screen. Cool. All right, let's run it. Boom, done. Okay, so I'm going to be trying to get through this a little bit faster because the videos end up getting very long, and this course is way longer than I expected when I initially took on the challenge to complete Codecademy as fast as I could. Okay, call and response. So we name a function and then we call it. Okay, that's really what we do with the function. Here we have a function called square. It takes in an input n. Then we define a variable called squared. It squares that input that we gave, so it goes n squared. These two asterisks mean this in math. Okay, so it squares the number, and then it does some string formatting here. So if, this %d gets replaced by whatever this n was, this %d gets replaced by whatever squared was, and then after we're done printing it out, we return what the value squared was. Okay, we've set up a function square, call it on the number 10 by putting 10 between the parentheses. So we're going to call it on the number 10. So here's how we're going to do it. If we did square and we ran it, it's going to give you an error because it's going to go back up to the function and it's going to go, okay, square of n. Then it's going to go to line 3 and it's going to say, wait, you never gave us an n. So it's not going to be able to square anything. But now if I give it a 10, it's going to go in here. It's going to be like 10 squared. Beautiful. And then it's going to say right here is 10 squared is 100. Right? Because that's the calculation over here, squared. And then it's going to return 100. Okay? Return is one of those things that is sometimes a little confusing. But I will show the difference between printing something back and returning something back right now to you guys, okay? I'm gonna do that right away. Okay, so let's say I define some function Bob, or let's make it define sum, okay? And effectively sum of A and B, all right? So sum takes in two inputs, A and B, and it just adds them. So I'm just gonna do return A plus B. When I use sum, I just do this and I get back whatever values, right? So this is 1 plus 5, you get 6, 1 plus 7, you get 8, 2 plus 7, 9. How this works is you call sum with inputs 1 and 5. It goes in here, it makes A1, it makes B5, and it goes A plus B. And that's how you get 6, 8, and 9 right here, okay? What we wanted to do was, what's the difference between return and print? Well, here, I can do v is equal to sum of 1 comma 5. And now v will be what? What do you think? V will be 6, okay? But let's go back to our function where we defined it. And let's define it as print A plus B. Like this, print A plus B instead of return, right? Now if I do sum of 1, 5, you still get the same looking answers. If I do sum of 1, 7, you still get 8. Everything looks nice, but if I do v is equal to sum of 1 comma 5, watch what happens. If I do v now, v doesn't have a value. Okay, v, it says, is just v. All right, v is basically nothing. So print just outputs something to the screen. So this just outputs something to the screen, whereas return actually returns a value that you can do something with, right? If it said return, you can also do something like plus 5. So this part will evaluate to 6, and then plus 5 will make it evaluate to 11. Whereas if you do it with just a v and you say print, this part is going to evaluate to pretty much nothing. It's going to print out 6 to the screen, and then this 5 is going to try to get added to a whole bunch of nothing. Okay, so print is not going to help you there. So that's a little difference between return and print. Cool. Let's keep going. All right, parameters and arguments. So we are now learning about parameters. I gave you guys a little sneak peek into parameters. Let's see what they want us to do. Replace this with parameters base. whoops, and exponent, a result is equal to base to the power of exponent, and everything else is already good, and 37 to the power of 4, and that's 37 to the power of 4 is 1,874,161. Pretty big number. One good turn. So this over here returns whatever you give it plus 1, deserves another, takes an n, adds 2 to it. Okay, very simple. Now they're showing us how functions can call functions. Okay, so let's take a look at their example. So you can see fun2 is calling function 1 with the input m and then adding 7 to it. So this function calls function 1, it goes right here, it does n times 5, so it'll take this number, multiply it by 5, return it, and then add 7 to it. Okay, so if we put in 5 right here into function 2, it's going to go to function 1, it's going to go 5 times 5, it's going to get 25, 25 plus 7, that's going to give you 32. Okay, so that's how that works. So let's look at the functions editor. One good turn, which adds 1, deserves, which adds 2. Change the body of deserves another so that it always adds 2 to the output of one good turn. Okay, so add 2 to the output of one good turn. Boom, simple. Practice makes perfect. Let's create a few more functions for good measure. The example above is just to show you blah blah blah. Here is the example. All right, it defines a function called shout, and you should use, you should verbally say these things out loud because of terminology is very important to learn. Okay, don't just say, oh yeah, it's the DEF thing or the def thing, right? Understand that DEF stands for define. Shout is the name of the function. Phrase is a parameter. Okay, the reason why I'm saying be so specific with your terminology and learn it really well is so later on you're gonna see it in books, people are gonna refer to it like that, and then when you have to search it up, that's how you're gonna have to search it up, right? So don't be so ghetto about it and lazy and just call it, oh, a thingy majigger in the parentheses, right? That's gonna throw you off. Try to actually learn what they're called and use it. Cool. So, pretty much define this to yourself. Use the correct terminology, but I'm just going to do that for you guys right here. So, define a function called shout, which takes in one parameter, phrase. If phrase is equal to the uppercase of phrase, then return your shouting. So, if basically you write something in all caps, it's going to say, hey, you're shouting. Otherwise, it will say, can you speak up? And how you can use that function is here. I'm interested in shouting. So if you call that function shout by passing in the parameter, which is I'm interested in shouting, it's going to go to the definition of the function and it's going to go, I'm interested in shouting is equal to I'm interested in shouting dot upper. That's going to evaluate to true, and it's going to say, hey, you are shouting. Okay, so if I took this whole thing and put it here, you're going to see it's going to return you are shouting. Okay, and that's the decision process that it goes through. Okay, first define a function called cube. So define cube, which takes an argument called number. Don't forget the parentheses and the colon. How I think of colon and then hitting enter after it is that it's like then. So I'm defining a function and then here's the block of code that comes next, okay? So colon, enter. Make the function return cube of the initial number. So we're gonna say cube of the original. Define a second function. Define a second function called by3 that takes an argument called number. If that number is divisible by 3, that should call cube of that number. and return its result. Otherwise, by 3 should return false. Okay, so let me take you guys through the logic of how I wrote this block of code right here. Okay, so how did I figure out how to do if a number is divisible by 3, right? How did I do this thing over here? What does that mean? Let me show you. If I did 9 modulo 3, I get a remainder of 0. That means 3 goes perfectly into 9, right? If I did 10 modulo 3, I'll get a remainder of 1. 3 goes to 3, it goes to 6, it goes to 9, and then it's like, but I can't go into 10, so I have 1 left over. That is called the remainder in math. Hopefully you've learned about it. And if you did it with, if you try to put 3 into something, that number is divisible by, then you'll have a remainder of 0, right? Like 9 modulo 3, you get a remainder of 0. So if you can see that the remainder is equal to 0 and you get a true, that means that number is divisible by 3. That's how I got that line, right? So whatever I put in, right? If I put in 11 modulo 3, is 11 divisible by 3? No, it's not, right? You get a remainder of 1, and so it returns false. That's where I got that modulo 3 equals 0. So if it's divisible by 3, cube it, otherwise return false, all right? I didn't have to say else, but I can. I'll just say it just to be, go along with what they're teaching. But you don't have to actually say it. Importing modules. Importing modules is so fun, you guys. Importing modules is amazing. It's the concept of using somebody else's code that they have taken hundreds of years and hours of time to write, and you just use this command called import, and all of a sudden you have a power of thousands of professional software developers who spent countless nights eating, what do they eat? Ramen noodles, and writing this code for you. And you got to use it by just using this extremely powerful command called import. Okay, so learn about import. This is going to be an important section. Effectively, what this is you just trying to use other people's code. You don't want to reinvent the wheel every time. If there's already some kind of mathematical crazy formula that does something, you don't need to reinvent it. That's partially the reason why you don't have to know all the math in the world to be a good programmer, to be an effective programmer, because somebody out there has already done the math. You just need to steal it or use their code, right? Don't plagiarize, but try to use their code. What did they say? Great programmers copy code, or good programmers copy code, great programmers steal code. Okay, I'm not advertising for actually plagiarizing code, but what I just mean is importing code and using libraries intelligently. Okay, so they're giving an example of a square root, okay? So if you did a square root of 25, you're not going to get an answer back. You're going to get an error. What you have to do for that is import a module that uses a function square root, okay? Square root, right? Again, let's go back to the terminology. SQRT, that's a function, and it takes in as input one number. So we gave it 25. So it takes in as input some number n. But we can't use SQRT because we never defined it anywhere, right? We didn't do this stuff with def SQRT. It takes in some number and then, return blah, 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 whatever, right? We never defined SQRT. So if we type this in now, we're going to get an error. So I'm going to do what they're telling me to do. See, SQRT is not defined. So now they're telling you how you can actually use imports. So we're going to say import math. And here we're going to do math.sqrt. So this tells Python not only to import math, but to get the sqrt function from within math. So we're importing a library, a giant library of functions, which is called math. And within that library, we want to get the function sqrt that somebody has written, and that's how we get it. And then we just pass in 25 to it. So the function is called sqrt. We are passing 25 to it. And the dot notation here is really telling us the path to that file. Okay, so if I hit save and submit, you can see that I get back 5, which is indeed the square root of 25. Another way to get a square root without using this is just do something to the power of half. Okay, that's another way. It's a pretty cool way to get a square root of something. All right, start next lesson. Function imports. So from module import blah. So we could have said from math import sqrt and then just done sqrt25. Okay, that's an example of a function import, and that's exactly what they're telling us to do. Boom, nailed it. Universal import. This is saying import everything as a function. So we can say from math import every single function, and now we never have to say math.sqrt or whatever. We can just say sqrt, and we don't have to say math.tangent. We can say tangent, like this, tangent of 90, right? I forgot what that is. It's been a while since I took trig. Let's give this bad boy a try, and it's pretty good. Okay. Here be dragons. So basically, be careful when you're doing this stuff. This is an advanced concept, and okay, we should mention it, but I don't want you guys to worry about it. It's just a waste of your time if you're actually starting out. So they're basically saying import. It's best to stick with either import module and type module.name, or just import specific variables and functions. So effectively what they're saying is avoid this thing with the asterisk. Okay, avoid it at all costs. And why they're saying that is, imagine you created your function called sqrt, or let's say you created your function tan, and maybe it was for I don't know, tandem. It was short for tandem. There's something called tandem chess. So it was really for tandem, and you said define tan, and it prints out, you are playing tandem chess, right? But now if you did from math import asterisk or whatever, and you used tan of 90, like, you're gonna start getting some errors. It's gonna be like, hey, do you want to use this function tan that you defined, or you want to use the function tan from the math module? So it's just better to say maybe import math. So now if you want to use your own tan, you can just say tan, or if you want to use the math tan, you can say math.tan, which tells it that it has nothing to do with this tan over here. Okay, hopefully that makes sense. Let's continue going forward. Okay, biggest number, smallest number, distance from 0, beyond strings. Now that you understand what functions are and how to import modules, let's look at some functions that are built into Python. No modules required. So a lot of stuff comes built in, right? Like dot upper, dot lower, str, len, right? A lot of those just come built in. These are great for doing work with strings, but what about something a little bit more analytic? So if we're trying to do something with math, right? Like, we're trying to find the biggest number out of all of these numbers. So if I gave you a giant list of numbers, how do you find the biggest number? Now, sometimes people will look at it and be like, these are just 4 numbers. But think about it. Sometimes maybe you could work as a data scientist, and you could be dealing with a file with a couple of gigabytes, and you have 10 million numbers, right? You can't visually scan it and pick the best number, and maybe a lot of softwares are going to fail. Even Excel a lot of the times will fail with file sizes so big. So maybe you have to use something with Python, and Python is gaining a tremendous amount of popularity, and you might have to use a function from Python. And so how are you going to use that to get the the biggest number from that, or the smallest number, or how far something is from zero. So distance from zero, right? In math, it's known as the absolute value. Okay, cool. So you can see the math library has all these functions. Cosine, cosh, asine, all of the ceiling, cosine, degrees, factorial, floor. Like these are all part of math. So you could do math.sqrt, math.pow, math.tan, so on and so forth. So here they're defining your own functions to figure out things. And you can see how you figure out the max number is just do max of that. Okay, so you just call the max function. Pretty simple. So now they're gonna take you step by step. All right, try out the max function on line 3. You can provide any number of integers or float arguments. So if I gave max 5, 10, -15, 20, -7, what max does, this function max right here, is going to figure out which one the max is. So you can see it's 20, and then it's going to print 20. Okay, this whole thing is going to turn to 20. That's what's going to happen. It's not going to keep that tuple there anymore, that thing in parentheses with a bunch of numbers, right? It's going to pick 20. The whole thing is going to convert to 20. And then it's going to print 20. Okay. All right. Minimum, same deal. Right? It's going to pick -5. The whole thing is going to turn to -5. And then we're going to move on. Boom. Done. Absolute. We're going to use the ABS function. And it's the same way. Right? It just tells you how far something is from 0. So if I did -100, it's going to give me back 100. Or they want us to use a specific value like -42. Cool. Now they are telling you about this function called type, which tells you the data type of something, right? So if I did type 1.4, it's going to tell me it's type float. If I did type of 1, it's going to tell me it's an, and you should know these now, it's an integer. If I did hello, this is an, or not an n, this is a string. Cool. Okay. So you can see their examples: integer, float, and spam, int, float, and string over here, right? String. Okay, so have Python print out the type of an int, float, string value. I'm just gonna save myself some time and copy those. Done. Review, yes. Okay, let's review functions. So we define a function. Again, try to speak this to yourself, then hear me do it. Define a function called speak, which takes in as a parameter or as an input a variable named message, and it just returns message. So it really doesn't do much. It just returns message. Okay, it just takes it and returns it. It doesn't really do anything. And then this part is outside of the function. So if you're happy, you call the function speak and pass in I'm happy. It goes to here and it just returns I'm happy. If you're sad, you go to the function speak and return I'm sad. Otherwise, call the function speak and go I don't know what I'm feeling. Okay, so here are a bunch of instructions, and they want you to create your own function. So let's get started. Define function, and it's called shut down, that takes in one argument s. Don't forget to put the parentheses or the colon. Then if shut down function receives an s equal to yes, it should return shutting down. Make sure to put the capital S there, otherwise you're going to get it wrong. Otherwise, else if s is equal to no, and there's a difference between 1 equal sign and 2 equal signs. 1 equal sign is an assignment operator. two equal signs is a comparator operator. It compares two objects. This equal sign will try to make S equal to no. This two equal signs checks if S is no. Okay, big difference there. Then the function should return shutdown boarded, else, other than those inputs, the function should return sorry. Okay, fairly simple, done. Next lesson. Modules, review modules. Now let's see what you remember about importing modules. Import the module math in whatever way so from math, import sqrt, function on the number 3689. I like to do it this way sometimes. 13689, right? That's what I did. Oh, I didn't print it. Cool, done. Review built-in functions. Perfect. Last but not least, let's review some built-in functions. So define a function called distance from 0 with one argument. Let's call it number. If the type of the argument, so if type of the argument is equal to an int, or that type is equal to a float, right? The function, and let's do that. Actually, let's check something. So let's do type of 5 equal to an int. That gives you a true. Okay, no, so I was right. I was doing it right. The function should return the absolute value of the function input. Done. If, right? Forgot to put the if there. Otherwise, the function should return nope. Done. Boom. Okay. So that was pretty great. We didn't call that function, so practice calling that function, okay? Don't just leave that function there, actually call it. And I think that was pretty excellent. I'm going to cut the video off here because it's already long enough, and we just finished this entire section. So I will see you guys in the next video in Codecademy Part 6. This is Clever Programmer, over and out. See you guys in the next video. Bye.